Hello, nice to have you. In today's class, we are going to be looking at simple calculations involving chemical equations. Having talked about chemical equations and how to balance simple chemical equations, it is very important that we solve some questions or some problems on simple chemical equations. The knowledge we've gathered from a balanced chemical equation indicating the number of moles of both reactants and products according to the law of conservation of matter that says that matter can neither be created nor destroyed. We can now go further to solve some simple examples involving chemical equations. Let's take a look at some common examples or some simple examples on some calculations involving chemical equation. Okay, so let's take a look at our question for today. Calculate the mass of iron produced from 10 grams of iron trioxide according to the equation below. So we have been given the equation of reaction here, and the number of atoms of the atomic masses of the individual elements that is required in the question are also given to us. Iron to be 56, carbon 12, and oxygen 16. We also have a balanced chemical equation in this case, so we are not bothered about balancing the equation again. We already have a balanced chemical equation. Now the B part of the question says, what is the volume of carbon 2 oxide required in the reaction? Now let's go to our solution to the question. Okay, so the first thing we do is to write the equation of reaction just as it is given to us in the question. So we have Fe2O3 solid plus 3CO gas to give us 2Fe solid plus 3CO2 gas. Okay, so this is the required chemical equation for the reaction. Now, here we can now indicate our number of moles. So I have 1 mole here. Here I have 3 moles of carbon 2 oxide. I have 2 moles of iron and 3 moles of carbon 4 oxide. So these are the individual number of moles of the reactants and products. Now, the next thing we do is, the question says we should calculate the mass of iron produced by 10 grams of iron trioxide. Now, of course, from our equation here, we can convert the number of moles to atomic mass. Okay, so here, converting this, we have, you can say 1 mole of iron trioxide produces, okay, 2 moles of iron. Okay, 1 mole of iron trioxide produces 2 moles of iron. Okay, now if 1 mole of iron trioxide produces 2 moles of iron, now what is the mass of 1 mole of iron trioxide? Okay, so 1 mole of iron trioxide is equal to 2 times 56 plus 3 times 16. Of course, the atomic masses of the elements have been given to us from the question. So what we'll simply do is to multiply them by the number of atoms. So that is what we are simply doing here. So we have, this will give us 160 grams of iron trioxide. Now, the next thing we do is, what is the mass of 2 moles of iron? Okay, so 2 moles of iron is equal to 2 times 56. So 2 times 56 will give us 112 grams. That's 112 grams of iron. So we can now see from the equation that 1 mole of iron trioxide produces 2 moles of iron, and the 1 mole of iron trioxide is equal to 160 grams of iron trioxide. So therefore 160 grams of iron trioxide will produce 112 grams of iron. Okay, so we have 160 grams of iron 3 oxide produces 112 grams of iron. Okay, so if this will produce 112 grams of iron, it means that 10 grams of iron 3 oxide is going to produce 10 times 112 divided by 160 grams, and this will give us 7.0 grams of iron. Okay, so 160 grams of iron 3 oxide produces 112 grams of iron. Therefore, 10 grams of iron 3 oxide will produce 10 multiplied by 112 divided by 160, and the answer is 7.0 grams of iron. So this is the required mass of iron that is produced in the question. Okay, now our B part of the question: calculate the volume of carbon 2 oxide required for the reaction. Of course, the carbon 2 oxide reacts with the iron 3 oxide to produce iron and carbon 4 oxide. So here we are looking for the volume of carbon 2 oxide that is required for the reaction. Okay, now just as we have done in one of our classes where we talked about the volume of a gas, of course carbon 2 oxide is a gas. So going back to what we did in that class where we said under standard temperature and pressure, 1 mole of a gas occupies a volume of 22.4 dm cube. So here we are going to convert the number of moles of the carbon 2 oxide to the volume. Now going back to what we have done before, we have 3 moles of carbon 2 oxide is required in the question. So 3 moles of carbon 2 oxide converted to volume will give us 3 times 22.4 dm cube. Okay, we can have here as 160 grams of iron 3 oxide requires 3 moles of CO. Okay, requires 3 moles of carbon 2 oxide, and the 3 moles of carbon 2 oxide is equal to, so 3 moles of CO is equal to 3 multiplied by 22.4 dm cube, which gives us 67.2 dm cube. Okay, so we can now say 160 grams of iron 3 oxide requires 67.2 dm cube of CO. Therefore, 10 grams of Fe2O3 is going to require 10 multiplied by 67.2 divided by 160 dm cube, and this will give us 4.2 dm cube of carbon 2 oxide, and that is the required volume of carbon 2 oxide that is needed in the question to react with 10 grams of iron 3 oxide. With that, we've come to the end of this class on simple calculations involving chemical equations. I hope we've been able to understand some simple steps on how to undergo some calculations involving chemical equation with just this simple example. Hope to see you in our next class where we are going to be looking at other important concepts in chemistry. Bye for now.